Hello everyone. So, 6.3, Laws of Exponents. Well, that's a fancy way of saying power laws. Now I know we did power laws from before, so we're just going to do a quick recap. Our first one will be the multiplication part. Okay? Multiplication between two numbers with the same base, we can add the exponents. All right? So what I did was I introduced a couple more examples. I have bracket times bracket. I have two coefficients, the 3 and the -4. Now the word coefficient is the correct name for the numbers in front of the variables. So under multiplication, 3 times -4, -12. Then the w plays with the w to the power of 10. Next example. Again, I have coefficients 5 and 7, so they take care of themselves, 35. I have x squared and y cubed. On the other side, I have w to the 5th, x to the 10th, y to the 20th. The w has no one to play with from the first bracket. No problem. It's like saying w to the 5th times 1. So it tags along for the ride. In the meantime, the x plays with the x, power of 12, and the y plays with the y, power of 23. All right, so that takes care of the multiplication. The next thing we introduced to you was under division. As long as I have the same base, we subtract the exponents. 2 to the power of 3. Now you'll notice that I made 2 to the power of 3 equal to 8. General rule, okay? If we have a number with a small enough base that we can crunch out a decent number, you crunch. If this had been 2 to the power of 30, I would have left it in its exponential form because 2 to the power of 30 would have been gigantic. Okay? So if you can crunch the number nice and easy, you're expected to do so. All right, next example. Still division. I have a negative divided by a positive. Negative overall. Takes care of the symbol. I have 45 divided by 5, 9. I have x to the 6th divided by x squared, x to the power of 4. Nice and clean. Okay? One more example. I have a positive divided by a negative. Negative. So the symbol takes care of the symbol. Then 200 divided by 40. X to the power of 8, x to the power of 5, x cubed on top, right? The y has no one to play with, so it tags along. Last but not least, z to the 4th divided by z cubed, z to the power of 1. Now I don't need to show the 1, it's understood. Any other exponent you need to show. All right? So that takes care of the division under power laws. Power of a power. Okay, so let's just take a look at these examples. So basically, power of a power means an exponent outside and an exponent inside a set of brackets. Power of a power. When this is the case, you multiply the two exponents. 2 to the power of 12. Now, you could argue 2 to the power of 12 is still crunchable. I can't remember if it's 4096, but whatever. It could be, right? But 2 to the power of 12, the exponent's getting up there. You might want to leave it as an exponent, okay? As compared to the example here, 2 cubed was 8. All right, so another power of a power, right? So this becomes, I deal with the exponent first, make it power of 6, and now it's -3, all -3, to the power of 6. Any negative number to an even exponent, right, will become positive. And then the 3 to the power of 6 is 729. Okay? Let's keep going. Here I have a coefficient in front of the x and the y terms. Power of 4 outside. Now you'll notice on my next line I've got 5 to the power of 4. The reason for this is any number that doesn't show an exponent is considered power 1. So when I have a power outside, power inside, I have to go 1 times 4, which gives me 5 to the exponent 4. When I crunch that, 625. Okay? In the meantime, 2 to the power of 4 is 8 for the x. 3 to the power of 4 is 12 for the y. Okay? Let's keep going. I have here bracket cubed. Again, the negative 3 is inside this bracket, and it has no exponent showing. So I'm going to treat it as if it is power 1. This is how I have negative 3 to the power of 3, and any negative number to an odd exponent is negative times negative times negative. When it's an odd exponent, the negative comes back in front. 3 cubed is 27. Notice the x was power of 1 as well. Now it's power of 3 outside of the bracket. The denominator still works the same as well. That's 5 to the power of 1. Now it's 5 to the power of 3. Y squared to the power of 3, y to the 6th. When I clean this up, okay, I've got negative 27 x cubed, 125 y to the 6th. I cannot do anything else to this. There's nothing that will divide out between the 27 and the 125. Power of 0. Okay. Now, I don't know how anyone has shown you this before, so I'll just go the way I go here. Any number to the power of 0 is equal to 1. So for example, 5 to the power of 0, 1. If I have this crazy bracket with all these pieces and outside is to the power of 0, this whole bracket, even though it's a negative, becomes power 1. And the reason is it's power of a power, so you give it power of 0, power of 0, power of 0. So each one becomes effectively 1 times 1 times 1 times 1. It's still a 1. So nobody bothers to do power of a power here. They default and say, okay, any number, this crazy bracket here, to the power of 0, equal to 1. All right, let's keep going. I wanted to show you this one because of the fact that the 18 divided by 3 cleans up, right, 6. But notice here, I'm going to have x squared divided by x squared. According to the division rule, that's x to the power of 0. Well, x to the power of 0 becomes 1. So really what you've got is you've got 6 times 1 times y squared. Okay, oh, and I got the y squared from here. So I don't even bother to show the x at the end. Okay, because it is equal to 1, it comes out nice and clean. All right. In the later grades, grade 11, 10, 11, 12, we start talking about negative exponents. Okay? So let's see what happens. So typical example, some number to a negative exponent. That negative tells me to flip the number to make it to a positive exponent. Okay, now I call this upstairs, downstairs. Okay, and I'm sorry I can't really explain it terribly here, but basically the negative 2 says I'm in the wrong apartment. This says upstairs right now. It should have been below or downstairs. Okay, once I have 1 over 5 squared, 1 over 25, because I can crunch the 5 to the power of 2. Similarly, I've got a power of a power law here. Okay, so let's do the power of a power law. X to the power of negative 6. That negative in the exponent says flip it. That's how I end up with 1 over x to the power of positive 6. Okay. Last but not least, a to the 5th, b to the power of negative 3. Now, if your final answer looks like this, that is called answer on one line. Okay, or results on one line. Most of the teachers, most of the textbooks default to always showing positive exponents. This is a more standard look. So what happens to this answer? Well, the final answer now looks like a to the fifth divided by b to the positive 3. Okay? And that's the point of leaving the answers with positive exponents. This is the more standard look. Okay? But effectively, the two of them equal each other. So now that you've had all the knowledge of all the exponents, we're going to combine them. All right, let's just get this out of the way. So, for example, 7 to the power of 2 times 7 to the power of negative 5. I'm going to use my power law first, right, because it's multiplication. 7 to the power of negative 3, the negative tells me to flip it. So it's 1 over 7 cubed now. And I can crunch the number, so 1 over 343. Similarly, okay, I have a whole bunch of variables involved here in a big fraction question. So the first thing I would do is I would look to put the negative exponents in the opposite apartment. This power of negative 2 on the y says he's not happy, he's in the wrong apartment, so he moved downstairs. Z to the power of negative 6 is in the basement, or the denominator. Negative 6 tells me Z is unhappy here. He wants to move upstairs. When you move them upstairs or downstairs, the negative exponent is taken care of. Now I use my power laws. Multiplication between them, Z to the power of 7. Multiplication between these two guys, y to the power of 7. Notice I had x cubed divided by x, so when I reduce it's x squared, and it's upstairs. Next example. I have bracket to the power of negative 3. Inside the bracket, I have 5 to the power of 1, no exponent is showing, x to the power of a negative exponent, y to the power of a positive exponent. So I'm going to do my power of a power law first. Okay, that gets everything out of the bracket. And now I deal with each one, right? So 5 to the power of negative 3 goes into the basement. Y to the power of negative 12 goes into the basement. X to the power of 6 was happy where he was. He stays upstairs. When I clean this up, I have 125. That's my 5 cubed. And the x and y terms stay put. All right, let me just continue on here. So, they're going to ask you to evaluate when, and they give you numbers for the x, the y, the z, and what other variables they're using, right? So now they're saying, I want an evaluate or evaluation or the value of the question. Okay, so in other words, crunch the number. Let's take a look at this example. Okay, so I have this crazy fraction here. Well, the first thing I'm going to do is I'm going to use my power laws as much as I can to clean things up. So you'll notice the y comes downstairs, makes it y to the 5th. 15 divided by 3 gives me the 5 upstairs. X had nobody to play with, so it stays put. Z had no one to play with, so it stays put. So now what I've done is I've kept my fraction, because it's still a fraction question, but you'll notice that all the exponents are positive and everybody's in the right apartment. Okay? Now that I've reduced as much as I can using my power laws, now I'm going to substitute in. The x goes here, the y goes there, z goes there. Next, I want to point out that whenever you substitute in, especially with power laws, you put brackets tight on the number. Okay? Reason, if you don't, then this looks bad and becomes maybe 5 minus 3 squared, which would be totally out to lunch. Okay? So when you do substitution, put tight brackets, plug the number in where they belong. Don't try to do plug in and crunch at the same time. You think you're saving yourself a step, but in hindsight, most people mess up. All right? So now that I've plugged in my numbers, now I'll crunch the exponent. At the end of this, I'm going to use BEDMAS as far as I can. And conveniently, there is no reduction of this fraction because there's no common terms or like terms. So it stays 45 over 128. Now, this is your homework, right? Please remember, I always assign what would have been the regular homework for that day had we been in day school. Under the situation, please be selective. Do one of 4 questions. Do not pick the same question over and over and over. Okay? Be selective. Make sure you get a different look on everything. All right, ladies and gentlemen, I hope that helped.